Hi everyone, let's see Johnson counter with 3 flip-flops, right? So Johnson counter means basically the last flip-flop complement output is going to be connected to the input of the first flip-flop, right? And all the remaining things as usually connected like this, right? Let's see how it is going to behave, right? So if you are going to take the present states, something like Q2, Q1 and Q0, right? So what might be the possibilities? If you are going to have 3 bits, 8 possibilities are there: 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1, right? So what might be the next states? So next states will be Q2 next state, Q1 next state and Q0 next state, right? So if you would like to write the Q2 next state, this will be the D flip-flop of D2, right? D2 get the input from the Q1, right? Q2n I can write directly as Q1, right? So 0 0 1 1 0 0 1 1, right? Next, what about the Q1n? Q1n will be a kind of D1 is going to be a Q0. So Q1n I can write as Q0. So 0 1 0 1 0 1 and 0 1. Good. What about the Q0n? Q0n is going to be the input of D0, meaning that whatever the value that you are going to pass at D0, that will be the output. But this D0 is depend on Q2 complement. So you can write them as Q2 complement, right? So Q2 complements with all zeros means 4 ones, all 4 ones means 4 zeros, right? To avoid the confusion, let's try to draw the lines. Yes. Now try to analyze it. So if you are printed the 0 0 state, it will move to 0 0 1. 0 0 1. Good. Done. If it is printed 0 0 1, it will move to 0 1 1. 0 1 1. If you are presented the 0 1 1, it will move to 1 1 1. If you are printed the 1 1, it will move to 1 1 0. Sorry, I should not write outside. I have to move to 1 1 0. If you are printed the 1 1 0, it will move to 1 0 0. Anywhere 1 0 0 is covered? No, not covered. If you are printed 1 0 0, it will move to 0 0. Move to 0 0, right? Yes. Anything is non-covered? Yes. If you are printed 0 1 0, printed the 0 1 0, it will move to 1 0 1. If you are printed the 1 0 1, it will move to 0 1 0. That's it. So this is the corresponding state diagram for the given Johnson counter, right? Now you can able to observe how it is working. This particular state diagram is working like a kind of mod 6 counter or not? Yes, mod 6 counter, right? So I can say that if I am going to have n flip-flops, you can able to generate definitely mod 2n counters, but not 2 power n counters. So to provide that example only, I have taken this particular, to provide that proof only, I have taken this particular example, right? Mod 2n Johnson counters. Okay, fine. If I am going to have n flip-flops, how many ring counters you can able to define? Right? Mod n counters. Am I right or not? Right? If I am going to have n flip-flops, I can able to define only n counters, mod n counters, right? Whereas coming to ripple counters, if you are going to have n flip-flops, you can able to generate mod 2 power n counters. You have to make sure that is difference, right? These are important, right? Yes. Not only this, we can able to conclude once again the remaining things, right? So what about the frequency? If you are going to have n flip-flops, or if you are going to have n bit ripple counter, how was the frequency? Frequency is going to be n by 2 power n. If you are going to have n flip-flops for mod n ring counter, definitely is going to be f by n, because its value is n. What about the frequency of n flip-flops where mod 2n Johnson counter is there? F by 2n. f by 2n is the frequency is going to be generated for the mod 2n Johnson counter, right? Yes. See guys, this particular Johnson counter I can able to use it for either mod 2 counter, or you can use it for mod 6 counter also, right? Because this particular thing will be used for mod 6 counter, and this particular thing we can use it for a kind of mod 2 counter, right? Yes, I hope I understood clearly. Thank you.